Does it take a really long time to get your developers ready to work on software? Perhaps you bring a new member on the team, or you're about to do a release to a new environment, and it takes much longer than you'd like? Well, stay tuned, because today we're going to be talking about how to use best practices for continuous delivery through infrastructure as code. Hi, I'm Jamie Edwards, and I help leaders of development teams and software companies to do a better job releasing their software, understanding what their customers need, and having a healthy environment where people can be as creative and innovative as possible. Today I'd like to talk about how we can use infrastructure as code to make releasing your software much smoother in a continuous delivery environment. Early in my career, I worked at a lot of companies that still used physical machines to release their software. They would actually have a physical server computer box that was the production environment. Now, some of these companies may have data centers that have racks of physical servers, but it was still up to somebody to actually purchase hardware before they could release their product. These days, through the advent of cloud technologies, hardly anybody does this anymore, but there's still many companies that have on-premise infrastructure or computing resources like servers that are not in a cloud managed by someone like Microsoft or Amazon, but they actually rent a physical space that hosts this infrastructure. Today I'd like to talk a little bit about how infrastructure as code can be used to release changes to these environments much quicker and smoother than you may have thought possible. When we talk about using infrastructure as code, there's some misnomers around it, so first I'd like to clarify this a little bit. You know, it's pretty common that someone who in operations or perhaps a developer knows how to actually go into a computer and install things. Things like on a Linux server, you may use package management to add packages to that server to get them ready to be in the state they need to be in so that you can host your software there. Similar to this, systems that provide a platform as a service in the cloud, like Amazon Web Services or Windows Azure, often provide a user interface through a website that someone can log into and click around and drag things and configure things to get computing resources into the state they need to be in to deploy your product to them. Unfortunately, the problem with this approach is, as the complexity of your product and infrastructure grows, having to remember what was done by pointing and clicking on things when you switch between your development environment, your test environment, your production environment, or any of the other environments that I talked about in the isolating customers from your changes video can become really difficult. As a solution to this, the industry has come up with many different technologies and tools that people can use to actually describe the state that a system should be in before you deploy your product to it. Things like Docker, Ansible, Chef, or PowerShell might come to mind. These are all tools that you can use to actually describe what should my production server or set of servers look like. What packages should be installed on them? Should there be environment variables that are set to a certain value? If we are running, let's say, a Ruby on Rails application, what version of Ruby might need to be running on it? In a .NET environment, what version of ASP.NET might need to be there? Now, in the past, people would actually need a new change in one of these environments and actually physically log into that environment, make the change, and then have to remember to go to all the environments, development, test, production, maybe your demo environment, and make that same change. And no matter how disciplined those individuals were, it was very common that people would forget to make changes consistently in all the environments. To address this need, we use infrastructure as code products to actually describe, I want a server with this CPU processing power, with this much memory, and this type of hard drive, and often the beginning of standing up this new infrastructure you're going to use starts with an image. So an image is, what you're usually used to if you have a home desktop computer and you're going to install, let's say, Windows or OS X or Linux on it. You may have a DVD that you use, or you may download a file like an ISO file from the internet, and you actually boot up that computer and it installs the operating system. Well, rather than doing that up in the cloud or in your data center, most companies start with an image that already has the operating system that they want to deploy their product. In addition to just the operating system, though, most companies will take the time to think a little bit about what that particular node of the infrastructure is going to be doing, and if there's any other things that need to be installed that take a long time, and add that to the image as well. A really good example of this is if you're hosting a database somewhere. Usually installing a database like, let's say, Microsoft SQL Server is a lot more difficult and takes longer than an open source database technology like MySQL or Postgres. So rather than having somebody have to actually kick off a script or log into a server and install SQL Server, an operations person or a developer or somebody with sort of a DevOps skill set can actually take an image and pre-configure it with SQL Server or CRM or a set of Rails packages or anything that you need to get that image ready to go. Now, in most modern high volume products today, there's actually not just one node hosting, let's say, your website, meaning one server or one virtual machine. You're probably going to have a lot of traffic if it's a successful product, and you're going to have multiple nodes that all receive traffic for the same type of infrastructure of your product. An example of this is if you have an API that you're going out and selling on the marketplace and people are paying you to hit that API to get something back from it, you may need 5, 10, 50 servers or nodes up in the cloud or on your data center somewhere just to support that load of traffic. Well, if somebody had to physically log in to all 5, 10, 50 of those servers, anytime there was a change that needed to be made to the infrastructure, that would cost a lot of time and money, and it would really be not the best use of people's time. So rather than doing that, there's various technologies that have come to the market that can be used to apply a set of configuration changes to a whole set of servers automatically through automation. Now, there's a couple different ways this can happen, and there's a lot of different terms people use, but I want to talk today a little bit just about the concepts of what's out there, and maybe when you're looking at the tool set your company has chosen, or you're out in the marketplace evaluating a set of technologies, I hope this video will help you understand which capabilities you're looking for and how they might fit your team and company better. So many companies that are new to infrastructure provisioning or infrastructure as code, they're used to when they need to make a change, an operations person or a developer logs into a server and makes that change. And it's really an anti-pattern or a bad practice, unfortunately, to continue to allow that to happen. So the goal you eventually want to get to in your products, if you really want to smoothly release software using continuous delivery, is you want to actually lock down servers to prohibit people from logging into them for all but the most exceptional of circumstances. If you do this, this is going to force teams to have to actually write a script or use a tool to introduce changes to servers. Now, why would we do this when obviously it's going to take more effort for somebody to write a script than to simply just log in and run a command? Well, remember, I talked about how as humans, we're not perfect. We tend to make mistakes, and it's just inevitable. If we want to make sure that anytime we need something to change about our product, that change is applied to all of our environments consistently: development, test, production. If you're doing A/B testing, you might have a whole bunch of production nodes. The only way to really make sure that happens is to use scripting technologies or automated infrastructure provisioning technologies to make those changes. An example of one of those is a tool like Ansible. This is a tool that you can use to describe a set of steps that should happen on a server or a set of servers. You can target those servers, run Ansible, and it will actually figure out which packages are already there. It will figure out, am I already at the right version of Windows? Am I already at the right version of Ruby? Do I have the right packages installed? And it will only apply the changes that are necessary. Now that's a good tool if you're still letting some people log into those servers, because if people forget things, it will sort of catch up and apply changes that were missed. In an environment that's more strictly controlled, where you're really locking people out, and I'm sorry, there's a plane going over right now, so hopefully it's not cutting me out too much. But in an environment where you're really locking the servers down and you're trying to get the team, the development and delivery team, much more disciplined about how they make changes to the infrastructure, you may find that a tool like Ansible or Chef or something like that, that takes a really long time for what it's buying you. If you know that your servers are in a given state and nobody's logging in and changing them other than through a script, there's overhead or processing time that it takes to actually let a tool like Ansible or Chef do all those checks to make sure, did I already make this change? No? Okay, make the change. Did I make this change? Yes? Okay, don't make the change. Versus if you just know this node is in a given state and I'm sure of it because I've locked it down, you can just say, only apply the things that have changed. And it's going to happen much quicker. So one thing you may want to consider as you choose an infrastructure automation tool or a tool for doing infrastructure as code is, how confident are you as an organization that you can really lock people out of those environments and get them to be disciplined enough about not logging into servers and making changes to them? If you're very confident about that, you may be able to use a technology that will run much faster and get your releases out much quicker. However, if you still are transitioning into this really full automation environment where infrastructure is no longer changed by people, again, except for in the very exceptional circumstances, you may still want to go with an infrastructure as a code solution such as Chef, Ansible, Puppet, and I'm just naming 3 of them. I mean, if you go out and search for these tools on the internet, you know there's probably like 50 to 100 different ones out there, and they all have different approaches, and I have no preference for which one you should use. They're all great tools, and you may even need to use a combination of them. So that's the first thing I wanted to talk to you about, was just to think about the maturity of your organization and how ready your people are for being essentially hands-off from directly accessing servers when you go to select that technology. The second thing I want to talk to you about is when people actually go onto those servers and make changes using the scripts, what's the best type of technology that would fit your company's skill set? So, as an example, software developers tend to be really good with object-oriented programming languages. Things like Ruby, C#, Java, Python. And if those are the types of people that will be actually making changes to your infrastructure, you may want to choose an infrastructure as code technology that lets them write C#, Java, Python, because it's going to be really familiar to them and they're going to be as efficient as possible and have the least chance of having to learn a whole bunch of new things they don't understand. However, if the people who are going to be maintaining and making changes to the infrastructure have more of an traditional ops skill set, meaning maybe they like Bash, shell scripts more, or they like PowerShell in a Windows environment, it probably makes more sense to have the thing that you use to do infrastructure provisioning use one of those technologies. No matter what you do, one thing you should also consider is that there are many vendors out there who are selling you a one-stop solution for automation and infrastructure as code. They're basically trying to corner the market and have a product that sells itself as, if you use our product to manage your infrastructure, it does everything. Now, There are a lot of good tools out there I've seen that do this. Terraform is one that comes to mind. It's actually really good at modifying Windows Azure resources, and it's able to modify AWS resources. It can modify Linux servers, Windows servers, and I actually think it's a great product. But one recommendation I'd like to give to you, and this is just a recommendation, it's not going to work for everyone, is that when you go to deploy your product into an environment, so the development team's been working on version 5 of the software, and they now are ready to push it into a test environment or a production environment. Something starts that process of deployment. Someone either goes and runs a script or clicks a button, or someone checks in code and there's a trigger that listens for that check-in and then deploys it, right? I mean, anybody who's watching this channel who's a little more familiar with automated deployment, you're going to be very familiar with that. I really recommend, and this has just been something that's really helped me in my experience, that even if you're using one of those off-the-shelf tools that presumes to do everything that you need to automate your infrastructure, don't have that be what you kick off when you go to change the infrastructure or you go to deploy your product. Here's why. If there's anything that tool doesn't do, now you need to find a way to piggyback some custom script or class library you write or helper function or something else to make the change that's necessary on that server that's not supported by that technology. And oftentimes I see teams then end up with this kind of complicated mishmash of all these custom things they've plugged into a tool like Terraform or Chef or Puppet that try to do all the infrastructure changes possible. Rather, and this is again just my recommendation, my opinion, this isn't a one-size-fits-all approach, but I've seen a lot of benefit to going about it this way. I like to have the thing that gets kicked off when you're going to go to do a deployment or you're going to go to modify infrastructure be a simple script of some sort, like PowerShell or Bash or a Ruby file, and it in turn calls, let's say, Terraform or some Windows Azure, release manager tasks or some AWS CLI tasks or, whatever else you're using to make modifications to the infrastructure. The reason why I tend to prefer this is if you think of a scripting language like Bash or PowerShell or something like that, it can call basically anything. And most automated deployment technologies and infrastructure automation technologies are a command line application of some sort that you're going to call. And those scripting technologies, calling a command line application is what they're made for. Versus if you find an off-the-shelf infrastructure automation tool that may have its own GUI or its own set of scripting files or a totally different language or syntax that you use, you're kind of at the behest of that tool vendor to hope that anything that you need to call or anything that you need to invoke or any other command line tools that you need to get running at certain steps of your process, that's going to work properly. Now, if you got a great tool and you seem to have found the perfect magical fit of all those things together, well then great, you're good to go. But if not, going with the route where you start with the thing that is your entry point to your infrastructure automation or the entry point to your deployment is a simple scripting technology. It's as flexible and open as possible. You can almost guarantee no matter what you need to do, there's a way that you can call it from PowerShell or you can call it from Ruby or Bash or whatever your scripting language is that you're going to use. So the last thing I wanted to talk a little bit about is, back in the previous days when people were doing prior to infrastructure as code, when people were more logging onto servers and making changes, well, and this was before having images that you could deploy. So an image that this image is, let's say, Windows, of a certain version and it's already got SQL Server, or this is a Linux box and it's already got Ubuntu at a certain version or something like that. Prior to that, it was very often that people would go to deploy a version of their code to a server and the server would have been changed and nobody would really know what was changed until something breaks or until much later. And one thing that a lot of cloud vendors have started to introduce that really solves this problem is if you're going to deploy, let's say, to production, rather than deploying your new version, version 6 or something that people have been testing for a couple hours if it's automated, or if it's manual, maybe people have been testing it for a few days or weeks. Rather than pushing that change into an environment, so a set of servers, if you're letting people log into them and change them that are in an unknown state, actually spin up brand new servers every time you deploy from the image and then deploy your release to it. What that's going to do is that's going to force people to always put anything about the infrastructure in that image or in the script I talked to you about that you would kick off. The bash script, the PowerShell script, the Terraform configuration files, whatever technology or set of technologies you've chosen to automate your infrastructure, if it's not in there and somebody went onto a server and just willy-nilly made a change, well, the next time the new version of production's hardware spins up in the cloud or in a data center, in other words, it's a fresh computer, this is now going to be production for this new release, and those changes go on it, the changes that somebody made manually to the old version of production, they're not going to be there. And that's a good thing because it's really forcing your team to stop logging into production servers or test servers or development servers and making direct changes. Because the only way you can get into a situation where you truly can achieve continuous delivery smoothly and not get into these situations where, well, why does it work on test this way? And in production, it works some other way. And in dev, this is configured wrong. And all these servers seem to be, the term Jez Humble uses, which I love, is a work of art. It's literally become like, I don't even know how the test environment got to be like this. Or I don't even know why production is so different from dev. I just hope the thing doesn't crash. Well, the unfortunate only way to dig yourself out of that kind of a technical hole of debt is to have an image that you use to deploy. And typically what ends up happening is, and this is different than A/B testing. I'm going to do a whole video to cover A/B testing because there's a lot around A/B testing, a lot of things you can use it for. But if you're going to spin up a new node of infrastructure, let's say for your website in production, it used to be on a virtual machine, or if we're using Amazon Web Services, it was an EC2 instance, or if it's Azure, maybe it's a cloud service. But it's basically got a server that's out there that's already ready to go. Production's website has been running on it. Now, when you go to deploy your new version of the product, let's say you're running at version 4 in production, and now the team's done all the testing, everything's good to go, you're about to upgrade production to version 5. Essentially, what you want your automation tool, no matter what you use, your infrastructure as code tool to do is spin up a new server, or again, if it's a large system, a whole cluster of several servers, and deploy that new release to that server. And you may use, again, Terraform, Ansible, Chef, Puppet, XYZ, whatever technologies you're using to get those servers in the state they need to be in prior to putting the product there. And then when you're done, there's probably going to be a set of tests I talked about in the video on using configuration management with continuous delivery about how important it is to actually test that the configuration is right on each release. So go back and watch that video. But let's say so you've spun up the infrastructure for the new version of production. You've spun up, you've applied all the scripts using infrastructure as code to change the configurations of the servers, anything that wasn't in the image when it spun up. Things like, maybe you need to set different environment variables depending on which node you're on. There's a variety of different things you might need to do. But usually the last step is after testing's happened, whatever testing is necessary, because I'll do a whole video on testing. Testing is a very deep topic. There's tons of different types of testing. But let's say all the automated testing that you've got running against production has passed. The last step you're going to do is you're going to change it so that customers that go to your website, let's say it's www.myproduct.com, change it so that www.myproduct.com no longer points to the old production servers. It now points to the new production servers. Now, once you do that, that's great. All your customers are now going to log in. They're going to start seeing the new product. A lot of people ask, though, what do I do with the old servers in production? And there's several different things you can do. One thing you can do is, if you want to do A/B, this isn't the same as A/B testing, but if you want to do A/B releasing, you can leave those servers up and have them be, remember I said the old version of production was at version 4, and then you deployed version 5 to a new whole cluster of servers. So now version 4 is sitting there, but it's idle. It's no longer being used. You can use those servers now when you go to deploy version 6, use those same servers, but reinitialize them with a brand new fresh image. Apply all that. So in other words, don't just use them as is, right? They've got version 4 running in them. You want to basically reset the state of all those nodes so they're totally clean, they're totally fresh, and you're going to put version 6 on there. So what ends up happening is, in production, you end up having basically an A environment and a B environment, and each time you deploy, only one of those environments in production, those sets of resources, is actually being served live traffic, and the other one's sort of staged sitting there unused, so that the next time you deploy to it, and then you turn off the old one. And you're sort of basically swapping back and forth between A is active, B is active, A is active, B is active on each release. Now, if you don't want to do this, because let's say the infrastructure in production is too expensive to afford both the A environment and the B environment, well, then you need a way to clean up the old servers when you're done with your deployment. And I wanted to talk with you a little bit about some of the trade-offs of how you do that cleanup. Now, the cleanest way to do it from a immediately reclaiming stuff you're not using standpoint would be, as soon as, remember in my example, you had the product running at version 4 in production on a whole bunch of servers. Now you spun up a bunch of new servers, deployed version 5 there, and now version 4 is no longer active. Well, you could have your infrastructure automation tool, your bash script, your PowerShell script, your Terraform configuration files, whatever you're using to do that work, as a final step, actually clean up or delete or get rid of all those production servers that are no longer in use. And that's going to immediately stop billing you if this is out in the cloud, or it's at a data center, and those nodes are now freed up for someone else who might be a customer of that data center other than just your company. However, you may want to leave those running for a while as a way to roll back. So if there's a problem you find with version 5 in production, and it's going to take you a while to fix it, and you need to immediately revert your customers back to version 4, if you leave those servers all running, even though they're not being used at first, you can now roll back by simply changing, like I said, let's say it's a website, the URL, www.myproduct.com. Oh shoot, we found a problem in version 5 in production. You can swap it over to version 4. Now, I won't get into if there's database changes, how do you handle rolling those back? That's a lot more complicated, and that's way outside the scope of this video. But when we talk about infrastructure as code, the main thing I want you to think about is, what are the technologies that are going to work best for the skill set of the team that's doing the automation? Are you putting all your eggs in one basket of one infrastructure automation technology, trying to force everything to happen in it? Or might you entertain what I recommended, which is start with a script of some sort, because it's going to be able to call anything. And then the last thing being, thinking about when you actually go to deploy places, what's your strategy for cleaning up things if you're doing A/B releasing? And if you're not doing A/B releasing, how are you going to make sure that when you deploy, you minimize the chance that people are actually logging into servers directly and making changes? One way that I see a lot of my clients do this is, let's say you're at a company where, even though they're trying to do DevOps, which I talked about in the continuous delivery video, where you've got, still a dedicated ops team and they report to an ops manager, and a dev team and they report to a dev manager, if you still got those people separate, or you've brought them together, there's typically going to be people who have been trusted with special permissions because they're really good with managing the production environment. What I often recommend to companies, or I'll see companies do that are trying to move towards a stricter control over their servers so that people aren't willy-nilly logging in and changing things, is they'll actually designate, let's say you've got 5 people with really great ops skill sets. There's really only one individual that's ever allowed to log directly into the production server, or maybe 2, and they know, they fully understand that they use those logins for diagnostic purposes, troubleshooting, in emergency situations only. They're not going to log in and actually add packages or configure environment variables. They're only going to do that through the scripts that the team wrote. As long as that's understood and that's followed, then it's okay to still let a couple people log into servers. But the biggest problem I see companies get into is when they don't want to get disciplined enough about using automation or infrastructure as code tools to make their changes, because it does take longer. And so, you know, a manager maybe comes to someone and goes, hey, there's an environment variable that needs to be changed in production. Quick, log in and change it. And sure, you're going to fix it that one time, but if you're doing A/B releasing, the next time you release, that environment variable is going to be wrong because it's not in your deployment scripts or your deployment infrastructure as code tools. So that's what I wanted to talk about today, was using infrastructure as code and some kind of good practices around how you might think about how it's going to work in your company and on your product. You know, again, there are so many different technologies out there, and there's so many different approaches, and I could probably talk to you about this for a day if we went into, you know, all the different ways it can be set up. But really, I want to hear from you. I want to hear how you've maybe used some of these tools to control what people are able to do, maybe some of the organizational policies that you've used at your company to prevent people from making changes, and really how you've used maybe security, how you've used some of these individual scripting tools to really prevent people from making changes to environments without going through these automated infrastructure as code technologies. So if you like this video, give me a like below, and please subscribe to the channel, and I'll talk to you tomorrow. Thanks.